Okay, so that's how the application topologies follow. So first, a client, if there are rack 1 and rack 2, so if a block 1 is stored in rack 1, the second copy will be stored on rack 2, like this. Let me show you with some different diagrams if that becomes easy. Okay, so let's first start with reading of a file, and then we'll go to how does the write operation happen. Let's start with the read. Okay, let's say I have, okay, so let's say I have some file present somewhere in the HDFS, and some client wants to read that file. Okay, so client could be anything. You have some program, or from some web UI, you want to view some file, so any client, right? So the first request is the open request. So you will, the client will say that, okay, open this particular file, right? Because read always starts with the open. I want to open some file. So it goes through some APIs, and it will go to the name node to get all the block locations. So the name node will say these are the blocks that you need to read. Okay, list of the blocks. So, and what is the list of the block? Which is nothing but total number of the blocks which a file has, right? So if file 1 has 3 blocks, so that those 3 location for all the 3 blocks will be sent back from the name node, and then it will start reading the file. So let's say it will start reading block number 1 from this data node. Okay, and all these are the one which actually contains the replicas, right? So in case if while reading this one failed, so it can automatically go and connect to the another one which contains the replica, and this process continue unless all the 3 blocks are successfully read. And once all the blocks are read, then it says close the file, and then it says okay, the file is successfully read, right? So this is the anatomy of reading a file. How does any HDFS client reads the file from the HDFS? Now similar to this, there is a process of writing the data as well. Okay, now what will happen while writing a data? The first step is this client will send a create request. Okay, so first step, I want to create a file, right? A new file. So the client has to send a create request. Create request will go to the name node, and name node will do some basic validations like this client has some write permission or not, whether this file is a new file or not, because if it is existing file, it will give an exception saying this file already exists. So either you have to create a file with a new name, or whatever, right? So you cannot create a file which already exists. That's all those basic checks name node will do, and then once everything is good, if it is a new file and the client has a permission to create a file, then the write operation will go. So first step in this is like you have to split up your data into blocks of the data. Right, so your bigger file will be split it into smaller groups, like smaller chunks of 128 megabytes, and those will become kind of a write packet, right? So you write your data to one of the data node, and name node will send a list of the data node on which we have to put the replicas and everything. and this list of the data node will become a pipeline like this, right? So the client will write a copy only on this node. So this is an important question. Sometimes in the interview they will ask, who is replicating the data, what time is the data getting replicated, is the application happens by the client, is the client going to replicate the data on all the three nodes? So there are some all this type of the questions sometimes it asks in the quiz and the certification exams. So see, the client is not replicating the data, the client is writing only one copy to one of the node. This pipeline of the data node, they are responsible to replicate among themselves. Okay, so the moment a block of the data is written to one data node, these three will communicate and they will replicate among them. Okay, and by default the replication factor is 3, which means by default Hadoop will store 3 copies of the data, and that can be changed, so we can make it 5, 6, 2, 1, anything, right? So depending upon the replication factor, this pipeline will be replicating all the data. So first block came, second block came, third block. Once all the blocks are successfully written, this particular write pipeline will be closed, and then it will say write is successful. Now sometime it is quite possible that this particular, while writing to this node, there is some issue that could be like this node is failed or network issue, or it could be any type of failure, right? So if there's an issue in writing to this one, right, if there's an issue in writing to one of the data nodes, so this data node will be discarded from this pipeline, and the write operation will go to the second one in the queue, right? So it will start writing to this one, and these two will be replicating, right? So instead of 3 copies, we'll have 2 copies of the data, because this one in the pipeline has failed. So can anyone tell me, like, if in this case if I have 2 copies, what will happen? Like, it will always remain 2 copy, or there will be some process to verify it and correct it? What will happen if I have under replicated blocks? This scenario is known as under replicated blocks. I was trying to replicate 3 times, but due to some error, some of the blocks were not replicated 3 times. So I have some of the blocks which are under replicated. Task manager will take care of this. So who is the task manager in this?
Job tracker.
No, job tracker will not come into the play, because job tracker is only responsible to process the data. It will never come into play till you are storing the data.
Whenever the replication is not completed, and so name node actually give an instruction to continue the replications. Is that right?
Yeah, so whenever there is under replicated blocks, how will name node come to know that some of the blocks are under replicated? Because if you really see, name node just gave a list of the data node, right? Name node just
Each
gave a
data node has to sync up, right? Each data node has to give a heartbeat to name node, say that this is the data I am completed or not.
absolutely. So that's what comes the this communication between data node and the name node, right? So all the data node have to give their block report. What are the blocks each one of them are containing? So once the name node will get all the report, it will come to know, okay, this many blocks are under replicated, and then it will start some process to replicate those under replicated blocks, right? So all of these things happens automatically. Okay. Now this replica placement strategy we're talking, right? So replica placement strategies, as we said, like name node will decide 3 data nodes, but what on basis, which basis, on what basis name node is going to decide these 3 name node? It's not randomly, right? So don't think that a name node will blindly choose some 3 nodes and it will give it will never do that. So it follows a block replication strategy which has a rack awareness in it. So instead of blindly starting, what it will do is it will say, if I have 2 racks, So you put the first copy in the same rack. So let's say this is my client. Okay, this is my client running on some node and it is writing some data. Let's say this is some uh, I have all this node, right? So I started putting the data from this node. So this client is running. So first copy will be stored on the same node, whoever client is creating the data. Okay. The second copy will not be put in this rack. The second copy will go to a different rack, and the second replica will be put in a different rack, and the third copy will put on a different node in a different rack. So what is the advantage of this? Let's say this node is down, so I have two copies, and if we are so unfortunate that even this node is down, but still we have another node which is having the same replica, so this ensures we have the maximum, we have the least. To set the replica as 5, so we'll have 5 copies of the replica. So in that case you can have some replicas in, let's say, first 3 in like this, and then you can have, if you have one more rack, so some of replica might go to another rack, or you might have 2 copies over here like this.
So that will be decided by the user or name node?
Name node, based on this replica placement strategy that we have given. So name node takes care of all of this. User don't say you put it over here or over there. Name node will decide.
Okay.
Okay. Yeah. So, and that's exactly the same thing like the way replica happens, right? So across multiple racks. Okay, so let's go into HDFS access. Now how can we access the HDFS? So there are different ways to access the HDFS data. The first thing is through the Java APIs, because everything is in Java, right? So there are some Java classes using which we can access the HDFS file. The second one is a web GUI, which is through the HTTP browser. So from the web interface, we can access the HDFS data. Or if, let's say, uh, I have some Python or C languages, so those wrapper can be used to access the HDFS data. Or there is a command line utility which is given to access HDFS data. So these are different ways. Either I can use through the web HDFS from the web using HTTP. I can access from the Java client or some other languages like Python or C, or from the command line utility which is already provided along with the software, right? So all these are different ways to access an HDFS data. So over here we have some small commands. We are going to quickly see how it works. Let me show you. So what you can also try is, for there is, you can go to the internet. You can download the Cloudera sandbox. Do you already have an environment with Hadoop running? Do you guys already have it, or in your company do you have some environment to run this type of test? Like, are you already
Not exactly.
are you already working some projects like Hadoop projects, or all in different technologies?
No, no, different technology.
Okay, so one of the quickest way to get started is just download the sandbox. Okay, so sandbox is kind of an image which is already created, configured, everything is ready. We just have to plug and play, right? So I will show you